Well, if you've been following me for the other videos, you know that I've been trying to get to 1,000 feet throwing a baseball with the MURLIN trebuchet. So here it is, 6 a.m. in the middle of June in Tucson. We're trying to get to that milestone once again with a number of improvements. The counterweight's up to 120 pounds from 90. I've reduced the inertia of the throwing arm, the frame has been reinforced, and a lot of hardware has been added to deal with the extra weight. So after a couple of preliminary shots to make sure that things are stretched out, and one misfire at 120 pounds, we're finally able to set up and get a good 120-pound shot off, and it is spectacular, or at least we think so. The analysis afterwards shows that we actually reach 80 meters per second with this shot, which is about 180 miles an hour, and that the distance is 234 meters, which is only about 750 feet. What we're not seeing in all this elation is that there's a number of problems with the shot. Just after the trigger is pulled on the high-speed camera, you can see that the counterweight cord actually jumps out of sprocket number 5 before either jumping back in on one side or going to the next sprocket on the other side. Also, if you're watching carefully, you can see that the counterweight hits the ground before the throw is actually complete. This robs the system of quite a bit of energy. We're not sure how much, but it definitely is going to reduce the final velocity of the projectile. Not knowing any of this, we set up for the third try and pulled the trigger. This time our luck runs out. The cord jumps out of sprocket number 5 just like it did on the previous two shots, but this time on the right hand side it curves back around and attaches to the bottom of sprocket number 5, so it's connected to the positive side of the sprocket on one side and the negative side of the sprocket of others, and things rapidly go downhill after this. The counterweight reaches almost entirely to the ground before the slack is taken up and bad things start happening. Arm number 5 is now subjected to about 1,000 pounds of force, which immediately snaps it, pieces flying some down and some towards the camera. The arm then comes to rest after being jerked to a complete stop, but in the process it splits itself lengthwise down the middle. In the process, the restraining sprocket, which is designed to keep the arm from over-rotating, is bent almost like a horseshoe. So now if you're looking for me, you will find me back at the drawing board trying to figure out how to deal with some of these problems. And then there's that other pesky question. How is it that 80 meters per second only gets me a 234 meter flight? I'm just going to have to go work it out. So stay tuned, more to come.